We're going to talk about some other types of equations today. So there's several other types of equations that we haven't discussed yet. This is our last lesson before test 1. So test 1 is going to be Monday the 22nd. Friday we'll review for it, and I'll talk a lot about the test in detail on Friday. But for now, I'll just mention a couple of key things. So test 1 covers all the classes we've done so far, all the materials we've looked at so far. There's a study guide for test 1 at the end of this packet, right? So this packet that we've been working out of. If you go to page 50, page is this? 51, study guide for test 1. There's a list of all the things you need to be able to do. There's a list of resources, which includes a practice test or a review for test 1 in my math lab. So that's optional. It's not assigned homework, but it's there if you want to do some extra practice. All the homework assignments and quizzes can help you review. And then I have a set of sample test problems on the following page for you to practice with also. And you can bring 1 page of notes with you to the test. You can write whatever you want on it, front and back, as long as you write or type it, okay, yourself. Okay, so you can't have a photocopy of somebody else's notes or print out a picture of your textbook, right? This is in the packet that we've been working out of all semester, and yes, it's also posted in Moodle. Yep. And then the next page starts some sample test problems. So this is to give you sort of the flavor of what the questions on the test will look like, right? They don't represent all the types of skills or problems that will be on the test. So when you take the test and if there's a question that you feel that this didn't prepare you for, tough, right? Something else should have prepared you for it, like your homework or a class example. But this is just to sort of give you a flavor, an idea of what the test questions will look like. So you've got a bunch of practice questions here, and then you have answers at the end, answers to those sample questions. So you've got those plus the My Math Lab review, plus make your own cheat sheet. So you got lots of resources. And one last thing you have in your packet also, page 49, is an equation summary study aid. So we have learned lots. By the time the test comes, we're going to have learned several different kinds of equations, right? So things that we've learned before today, we already knew linears. We learned quadratics last class. Rationals, that's equations with fractions in them. We've already done those. Get rid of that one. That one's not on the test. Inequalities involving fractions or factors you can get rid of. And then solving graphically, we also have already done. Okay, but finding an intersection point. Okay, so this little chart is just a handy way for you to like put all the different kinds of equations in one chart. And you could use this as your reference sheet to bring to the test. You know, you could fill this out and then you could use the back of it for any other material you want. You don't have to use this. I just thought it would be helpful for you. So use it if you want. The one I crossed out is the second to last one. Yes.
Is it going to be standard practice for the rest of the exams if you get to bring a study sheet? Or
yes. Yes, for all the tests, you get to bring 1 test. For the final, you can bring 4 pages of notes. Yeah, so the purpose of that is that you make good cheat sheets for your first 3 tests and save them. You can bring them back to your final. Plus, you get 1 more. Or you can start from scratch and make 4 fresh ones if you want. But yeah. All right, so that's just a little bit about the test. I will talk more about it Friday when we review for the test. But just wanted to give you a little heads up if you wanted to start preparing that you have some resources. All right, I'm going to skip over the preview exercises, and we're going to go to the teaching demo. So we're going to look at 4 or 5 other kinds of equations today. The theme of today is if you don't know how to solve it, try to turn it into something that you do know how to solve. Okay? So usually you can do that in a step or two. Okay? If it doesn't look exactly like something you already know how to solve, usually a little tweak, a little manipulation can turn it into something that you know how to solve. So polynomial equations, typically you can solve them by factoring and using the zero product principle. Warning though, do not divide both sides by an unknown, right? Don't divide both sides by x. Don't divide both sides by x squared, because we don't know what the solution is yet. And what if the solution is x equals 0? If you divided by x, right, you just like made the world explode, right? So you don't want to divide by a variable, or don't want to divide by an unknown. Instead, get everything onto one side. So in this case, I would move my 6x squared to the left-hand side of my equation. So I have x to the 4th plus x cubed minus 6x squared equals 0. So just like with quadratics, you want one side to be 0. And just like with quadratics, you just cross your fingers and hope it will factor, right? So typically with a polynomial, we look for a GCF. So all 3 of my terms have at least how many x's in there? 2. So I can factor out an x squared. And I'm left with x squared plus x minus 6 equals 0. And x squared plus x minus 6, does that factor? Yes, so this actually continues to factor. I've got x squared here. And then x squared plus x minus 6, that factors to x plus 3, x minus 2. Now I have a multiplication problem. I have multiplying 3 quantities together, and I'm getting the answer is 0. What's the only way you can get 0 as the answer to a multiplication problem? At least one of your factors has to be 0. One or more of your factors is 0. So either x squared equals 0, or x plus 3 equals 0, or x minus 2 equals 0. And those are inclusive ors. It doesn't mean only one of them, but one or more of them, right? So I solve each one, and each one is a solution. So in this case, I get x equals 0. In this case, I get x equals -3 because I subtract 3 from both sides. In the last case, you add 2 to both sides, and you get x equals 2. 3 solutions. And it turned out x equals 0 was a solution, which means it's really good I didn't divide by an x, right? Because we would have caused a black hole or something. Actually, we would have just lost a solution. Had you divided everything by x squared, when you finished solving, you would have just gotten the -3 and the 2 as answers, and you would have only gotten 2/3 of the credit on the problem because you lost a solution. All right, so polynomial equations, the key is to factor. Next kind of equation, radical equations. So the key is to isolate the radical, get the square root thing by itself, isolate the radical, and then raise both sides to an appropriate power. So I want to isolate the radical first. So what do I do to get that by itself? Minus x from both sides. Okay, so I get the square root of x equals 12 minus x. Right, so step 1 was isolate the radical. Step 2 is to raise both sides to an appropriate power. I'd like to get rid of the radical, right? I don't really want to have a square root in my equation because it makes it look complicated. How do you undo square rooting? Square. So I'm going to square both sides here. Okay, so the square root of x squared gives me x. 12 minus x squared means 12 minus x times 12 minus x. You got to be careful to actually write that out and FOIL it out, multiply it out. It's a really common mistake to do 144 plus x squared. right? But it's, you actually have to multiply it out, and you end up with x equals 144 minus 12x, which is minus 24x, then plus x squared. All right, how do I solve this new thing I've created? You want one side to be 0. Yep, so I'm going to move the x over, and then I'll have a quadratic, right? So this becomes x squared minus 25x plus 144 equals 0. So all I did was minus x from both sides. All right, x squared minus 25x plus 144, does that factor? Maybe, yeah. I don't know off the top of my head. I got to think of factors that multiply to 144 but add to negative 25. So I know 12 goes into 144, but 12 isn't going to work because 12 and 12 makes 24, not 25. So I have to think of some other factors of 144. What goes into 144? 4? 4 and 36. Can I combine those to make 25? No. How about, I don't know, 8? 8 and 18? Nope. What else goes into 144? 6 would have to, yeah. 6 and 24, but that's not going to give me 25. 16, let's try that. 16 and 9, yes, they add up to 25. 16 and 9. All right, so I should be able to do x and 16 and 9. And I need my product to be positive, but my sum to be negative, so I'll make these both negative. There we go. Then I have a multiplication problem. I'm multiplying two quantities together. The answer is 0. So at least one of those two quantities has to be 0. So I set each one to 0 separately and solve. So x is 16 or x is 9. But I should really double check my work here. X plus root x equals 12. Let's just check. X plus root x equals 12. If I plug in a 16 plus root 16, does that equal 12? No, because 16 and 4 is 20, right? Let's check the 9. 9 plus root 9, does that equal 12? Yes, so this one works, this one doesn't. So we cross this one out. This is what we call an extraneous solution. Extraneous meaning extra, like it popped out as an extra solution that wasn't actually true. This happens a lot when you're solving radical equations. So while you should always check all of your equation solving this way by plugging your solution back in, definitely do it with square root equations because you might get an extraneous solution. Yeah, any kind of root equations, yeah. All right, questions here? Okay. Let's look at equations with rational exponents. So rational is just another word for fractional, right? So I want to be able to solve an equation where the exponent is a fraction. So the key is to isolate the term with the rational exponent, and then you have two methods to choose from. We'll go through both of them. So step 1, though, is to isolate the rational exponent. So I want to get x to the 3/4 by itself here. So add 6 and then divide by 3. So I get x to the 3/4 equals 2. All right. Method 1. Method 2. All right, so in method 1, I'm going to convert this, the 3 and the 4, to a power and a root, right? Remember, the number on the bottom is a root, the number on the top is a power. So this says that the 4th root of x cubed equals 2. And now I'm going to undo the 2 things that are being done to x separately. So x is being cubed and then 4th rooted. How do you undo taking a 4th root? Raise it to the 4th power. Raise to the 4th power both sides. So then my 4th root and my 4th power cancel, so I'm just left with x cubed. 2 to the 4th is 16. Okay, and then undo the cubing. How do you undo cubing something? Take the cube root. Cube root of both sides. The cube root of x cubed is x. The cube root of 16, no. 2 root 2. Yeah, 2 root 2. Or just cube root of 16, right? So step 1, always isolate your term with the rational exponent. And then here in method 1, you break that rational exponent down into the 2 things that are being done to x, a root and a power. Undo each of them separately. In method 2, which I gave you a little preview of in the preview exercises, if you got this far, start with x to the 3/4 equals 2. And what I'm going to do is I'm going to raise both sides to a power. I'm going to raise both sides to the same power. The question is, what power should I raise it to? The 4/3. Yeah, how come, Anna? Yeah. Yeah, when you raise a power to a power, the rule for exponents is that you would multiply them together. So what I want to end up with is x to the 1st here, right? Or plain old x to the 1st. So what I have to put in that box so that 3/4 times what gives me 1 is the reciprocal, 4/3. 3/4 times 4/3 gives me 1. So if you raise the left side to the 4/3, raise the right side to the 4/3. So this becomes x, and 2 to the 4/3 is 2 to the 4th cube rooted, which is the cube root of 16, which is 2 cube roots of 2. And I forgot to put the cube root symbol in that one. So whichever method you choose is your choice. You can do whichever one. Questions? All right, let's look at absolute value equations. The key to absolute value equations is to isolate the absolute value. So it looks like the absolute value of some stuff equals a number, and then convert to 2 equations. The stuff equals the positive number, the stuff equals the negative number. Okay. If the absolute value of some stuff is 11, either the stuff in there equals 11, or it could be that that stuff is really negative 11. Because if 2x plus 1 were negative 11, its absolute value would still be 11, right? Because the absolute value of 11 is 11, and the absolute value of negative 11 is 11. So 2x plus 1, what's in the absolute value bars, could be either 11 or negative 11, and then its absolute value will still be 11. So you convert an absolute value equation to 2 equations, and then you solve both of them. So this one I get 2x equals 10, so x equals 5. And this one I get 2x equals negative 12, so x equals negative 6. And then we can do a quick verify here. I want to plug these into my equation just to show that I get a true statement. So the absolute value of 2 times 5 plus 1. What's 2 times 5 plus 1? 11. So this is the absolute value of 11. Does that equal 11? Check. Okay. Let's use the negative 6. Absolute value of 2 times negative 6 plus 1. What's 2 times negative 6? Negative 12. Add 1, you get negative 11. What's the absolute value of negative 11? 11. So they're both solutions. Okay, almost done. We're done with equations. We're going to look at 2 different kinds of inequalities now. Okay, so the key to solving a linear inequality is to treat it just like a linear equation with one small difference. If you multiply or divide both sides by a negative number in the process of solving, you have to reverse the direction of the inequality, right? The alligator turns around. Okay. So if you multiply or divide by both sides by a negative, just in your natural process of solving, the alligator has to turn around. So negative 4x is less than 8. The alligator is eating the 8 right now, right? If I wanted to solve this, my natural instinct would be to divide both sides by negative 4, right? To get that x by itself. Divide by negative 4, divide by negative 4. The 4's cancel, and you get x on the left, and on the right you get negative 2. But because I divided by a negative, turn the alligator around. And you end up with x is greater than negative 2. Here's sort of it's kind of a strange rule, but let's look at it in another way that might make it clear why that rule has to happen. Okay. That's just the original equation, right? If I add 4x to both sides, okay, there's no rule about adding or subtracting. I can add and subtract to both sides and the alligator never moves, right? So this becomes 0 is less than 4x plus 8. Subtract 8 from both sides. So you get 4x bigger than negative 8. Okay, so my alligator has not moved. Now I'm going to divide both sides by 4. Okay, and I'm not multiplying or dividing by a negative, so my alligator isn't going to change direction. I end up with an x on the right. Alligator's eating the same direction it was before, and I get x is bigger than negative 2. Those 2 things that I circled, do they say the same thing? Yeah, because in both cases, the alligator is eating the x, right? So it says x has to be bigger than negative 2. Okay. Compound linear inequalities. So this is when you have a sandwich, an inequality sandwich, and you're trying to solve for x. So the key to solving a compound inequality is to treat it like an equation that has 3 sides, right? It's like a club sandwich, right? It's got 3 sides. So whatever you do to one of the 3 sides of your equation, you have to do to all 3 sides. And your goal is to get x by itself in the middle of the sandwich. So my goal to get x by itself in the middle here, what do I have to do here? To add 4. So I have to add 4 to all 3, quote, sides of my inequality. So negative 6 plus 4 is negative 2. Here my 4's canceled and I got an x. 1 plus 4 is 5. And there's my solution. My x's have to be between negative 2 and 5. Or if you wanted to use interval notation, you would put negative 2 comma 5. All the x's between negative 2 and 5. Don't include the negative 2, include the 5. You can write the solution either way unless one thing is specified. All right. It was kind of a lot. There's a bunch of new kinds of equations, but they do build on each other. So it's probably a good idea to start some practicing.